Welcome to Beta Training and Support Online Education. In this video, we are going to present two questions uh, for the 10th standard CBSE Mathematics on the topic quadratic equations. These two problems are based on the nature of the roots of a quadratic equation. And both these problems are 3 marks questions. Let us see the first question. The definition of problem 1 is, this is a 3 marks question which appeared as question number 30 as a choice question in a periodic test in a school. If the equation 1 plus m squared into x squared plus 2mcx plus c squared minus a squared equal to 0 has equal roots, then show that c squared is equal to a squared into 1 plus m squared within brackets. Pause this video if you would wish to give this problem a try. And when you are ready, let us see the solution. First, let us go to the key concepts, go through some of the key concepts of this problem. In this problem, what are the key concepts that are involved in this problem? This is a question on the nature of roots of quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0. Here a, b and c are real numbers and x is the variable and a is not equal to 0. Then only it can be a quadratic equation, because its quadratic equation is of degree 2. It's the equation of one variable involving one variable of degree 2. The degree of a quadratic equation is 2. The solution of the quadratic equation is called a root. It is the value or values of the variable x which satisfies this equation. Since the degree of this equation is 2, it will have two roots. The roots may be real and equal, or real and distinct or unequal, or it may not have any real roots. In this question, it is given that the roots are real and equal. Now, how to find the nature of the roots of a quadratic equation? In the quadratic equation ax squared plus bx plus c equal to 0, the discriminant d is equal to b squared minus 4ac. The discriminant determines the nature of the roots. If d is greater than 0, the roots are real and distinct or unequal. If d is equal to 0, the roots are real and equal. If d is less than 0, the roots are imaginary or there are no real roots. See, in this question, we have been given that the given quadratic equation has equal roots. So it is clear that we should use the condition d, the discriminant d is equal to 0. That is, b square minus 4ac is equal to 0. Let us go to the solution. First, in this the thinking skills, what we have to think of is the condition, applying the condition. Find the discriminant and equate it to 0. So this is a given quadratic equation, 1 plus m squared of x squared plus 2mcx plus c squared minus a squared equal to 0. For convenience, let us assume that the standard form of the quadratic equation as capital A, we use capital A, B and C to distinguish actually instead of the lowercase letters, since already small letters A and C appear in the given quadratic equation. So to avoid the confusion, just let us use the standard form as capital A x squared plus capital B x plus capital C equal to 0. That is applied here. This is the solution to the given problem. Let us quickly go through this solution. If the equation now has equal roots, then we should show that this is the question again. On comparing this equation, the given equation with the standard form, capital A, the coefficient of x squared, capital A is the coefficient of x squared. What is it? 1 plus m squared. B, capital B, the coefficient of x, it is equal to 2mc, and capital C is equal to c squared minus a squared. That is the constant term. Since the equation has equal roots, d is equal to 0, so we have to find b squared minus 4ac and equate it to 0. Now let us focus on the question again. The given quadratic equation, we will be using this discriminant. We'll substitute these values of a, capital A, b and c in the given condition, that is the discriminant b squared minus 4ac is equal to 0. Thereby we get 2mc the whole squared minus 4 into, within brackets, 1 plus m squared into, this is that 1 plus m squared is a, into c is capital C is c squared minus a squared equal to 0. So we do this a little bit of manipulation. This question involves a high level of manipulation skills, simplifying an expression using multiple level of brackets. So be careful to do the simplification. Try it yourself, but it is given here. You could follow the steps carefully. See, we are using this 4 m squared c squared. On squaring 2mc, we get 4 m squared c squared minus 4 is outside. I'm using, we are actually introducing one square brackets purposely just to avoid mistakes creeping in this step, because there is a sign change, there is a brackets involved in this. So 4 into, we use the distributive property of multiplication over addition here and so subtraction or whatever it is. We are using 1 first and then we are multiplying by c squared minus a squared. Then plus m squared is multiplied again by c squared minus a squared. All this is put within the bracket, within the square brackets, is equal to 0 again. 4mc squared c squared minus, we go through inside, we just multiply that 4 inside, 4c squared. Now the sign changes, as you can see, there is a minus 4, minus before the brackets. So when you remove the brackets, that minus into minus becomes plus now. The sign changes to plus 4a squared. The plus m squared becomes minus 4m squared when it is multiplied by a minus. M squared c squared, of course. Again, there is a minus there, m squared a squared, which changes to plus 4m squared a squared equal to 0. Now it becomes very simple because 4m squared c squared gets cancelled out. Plus 4m squared c squared minus 4m squared c squared. It is getting cancelled. So we are left with minus 4c squared plus 4a squared plus 4 m squared a squared. There are only three terms now equal to 0. Now you can easily see on dividing by 4, 4 is throughout everywhere. So on dividing by 4 and simplifying by transposing the terms to the RHS and factorizing the expression, taking a squared outside on the right hand side, we will be getting the required result. C squared is equal to a squared into 1 plus m squared within the brackets. And this is the required result which is proved. Hope you understood this. Now there is a similar question. Let's go to the second question. A question that is similar to this but slightly more difficult than this. It's not so easy. Anyway, in this video we'll present the definition. First, the definition of problem 2 in the second part of this video. Here is a similar question on the nature of roots again, the same concept. If the roots of the quadratic equation p into q minus r of x squared plus q into r minus p of x plus r into q minus r is equal to 0 has equal roots, then show that 1 by p plus 1 by r is equal to 2 by q. Note that the algebraic expression on the left hand side on the LHS, the equation, is a cyclic symmetric expression. It follows a certain order and it is known as a cyclic symmetric algebraic expression. Pause this video at this stage to think of a solution. Try to do this problem as we did the previous problem 1. But it will be, you might get stuck somewhere, I'm sure of that, but you may give it a try. And when you are ready, let us see the solution. The key concepts used in this question are the same as in the previous question, that's the problem 1. So we go directly to the solution to the given problem. This question uses the same concept as in problem 1. So in this, what we do is, the given equation is p into q minus r of x squared plus q into r minus p of x plus r into p minus q is equal to 0. On comparing this with the standard form of the quadratic equation, which is ax squared plus bx plus c equal to 0. A is equal to p into p minus q minus r. The coefficient of x squared, a is equal to p into q minus r within brackets. The coefficient of x, b, is equal to q into r minus p within the brackets. And the constant term c is equal to r into p minus q. Since the equation has equal roots, we have d, the discriminant, is equal to 0. So again we have to find b squared minus 4ac and equate it to 0. That is what we will have to do. Now let us come to this applying the condition now. Substituting the values of a, b and c in the given condition, b squared minus 4ac is equal to 0. So b squared, q into r minus p, the whole squared. Within the whole thing is squared because it is b squared minus 4 into p into q minus r into r into p minus q within brackets. That is 4ac. It represents 4ac equal to 0. So this is an equation now. So as you go along, you will find this expression seems to be a little bit complicated, but it might take a little bit more time. But we just go ahead with the simple concept of expanding this r minus b the whole squared with a minus b the whole squared as a squared minus 2ab plus b squared. So q squared into r squared minus 2pr plus p squared within brackets. That is one expansion. Minus 4pr, again we expand the do the expansion of this algebraic expression. So it all uses that simple concept of distributive property of simplifying algebraic expressions. If you are not able to understand, you just refer to some concepts of simplifying algebraic expressions. Just go through the steps carefully. That after this equal to 0, we are removing the brackets at step by step. There is an multi-level brackets after 4pr. You just note that we have introduced square brackets there because there are already some lower level brackets inside. So we have to use necessarily the square brackets to distinguish between them. And there is also a minus sign, be careful. There is also a minus sign before the 4pr. So these are the words of caution here. While simplifying, you should see the change of sign and very careful about that. As we now go on to simplify this equation further, q squared r squared, of course, we just multiply inside the brackets. Minus 2pq squared r plus p squared q squared minus 4pr. Now what we do is we simplify the expression within the square brackets first, according to the hierarchy of brackets. Parenthesis. First you do the innermost brackets. We do the innermost brackets. What we do is we do that expression of q into p minus q, and then we do the r into p minus q. That's all. That way we can simplify it easily. So we get 4pr is remaining outside itself, and within the brackets we have pq minus q squared minus pr plus sign changes there. Because there is a minus sign before the brackets, it becomes plus qr. Minus into minus plus is equal to 0. Again, we have q squared r squared minus 2pq squared r plus q squared r squared minus 4p squared. Now we do the multiplication inside the brackets. We remove the brackets now. The minus sign is outside. So as we move along, the sign changes. Signs inside the brackets will change as we remove the brackets. Plus 4pq squared r plus 4p squared r squared minus 4pq r squared is equal to 0. That you should understand this one. This step is very important. As we move on to the next step, the final step of simplification to get the required result. This question is rather a complex question in terms of manipulation skills. It requires a high level of manipulation skills. So this is important. How we simplify. See, q squared r squared, we got it the previous step. It is reproduced here again. Q squared r squared minus 2pq squared r plus p squared q squared minus 4p squared qr plus 4pq squared r plus 4p squared r squared minus 4pqr squared equal to 0. The terms minus pq squared r and plus 4pq squared r are like terms. So we can note that, and they can be combined together by simple addition or a subtraction here. Here in this case it's a subtraction because they are opposite signs. On further simplification we get q squared r squared plus 2p. So it becomes plus 4 q pq squared r minus 2 pq squared r becomes plus 2 pq squared r plus p squared q squared minus 4p squared. The other terms do not undergo any change, so they remain the same. Further, on rearranging the terms suitably to get the famous algebraic identity x plus y plus z the whole squared. Of course, I would like to tell you this identity was learned in ninth standard. Ninth standard on the chapter polynomials, algebraic identities. So recall it, x plus y plus z the whole squared is equal to x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx. The famous extension of the x plus y the whole squared identity, this is called. So when you recall that, you just have to group all the terms, the square terms. See, q squared r squared plus 4p squared r squared, q squared r squared plus 4p squared r squared plus p squared q squared. Then there are some terms which are that 2xy, 2yz terms coming here, minus 4p squared qr plus 2pq squared r minus 4pqr squared equal to 0. Now, how to find out which is a minus and which is a plus? There is a simple thing here. See, there are two negative terms. Look at the terms minus 4p squared qr, and there is another term, a negative term, minus 4pqr squared. So there is a qr term which makes it negative here, and there is a pq term that makes it negative over there, that 4pqr squared. So both are 4pq here, and there is a 2pqr. There's a very important thing is there is qr over there. So pq is a negative now. Because of that negative sign over there, we choose that as a negative one. So we take minus pq plus minus qr plus 2pr the whole square. So of course, if you expand it, you will find this expression to come. When minus pq is squared, it will get plus p squared q squared over there. When minus q r the whole squared comes, it will get q squared r squared, becomes plus there. And 2pr the whole squared gives you 4p squared r squared, which is a plus there. The other terms, when you combine two ab terms, 2xy, 2yz and 2zx, you can work it out and see. This is an important thing which you have to find out from the sequence of the identity. Now the square root, that is, you take just minus pq minus qr plus 2pr is equal to 0. Actually, the square, it is whole square equal to 0. So we take minus pq minus qr plus 2pr is equal to 0. And transposing with change of sign, we do some simple manipulation here. We change pq and qr to one side. and 2PR and QR. So we will be getting 1 by R. Now we have to divide each term by this one. And finally, there is a mistake over here. Just correct it if you want. If you wish to, if you spot the mistake, immediately you correct it. PQ plus QR and not PR. It should be QR is equal to 2PR, because PR is already appearing on the right hand side. So it should be PQ plus QR. And when when the 2PR goes to the right hand side, it becomes minus 2PR. All are minuses. So it becomes PQ plus QR, not PR, is equal to 2PR. So on dividing each term by the PQR, which is the LCM of the denominators, PQR, we would get the required 1 by R plus 1 by P is equal to 2 by Q. This is the required result to be proved. But it was really complicated, I think so. But it requires a rather high level of manipulation skills, and try to work it out. Thanks for watching, and please subscribe to our channel Beta Training and Support Online. Thank you.